Our solar system, a cosmic neighborhood. What is the solar system? The Sun and everything that orbits it. Our solar system consists of the Sun, 8 planets, 5 officially recognized dwarf planets, hundreds of moons, millions of asteroids, and billions of comets and meteoroids. It's located in the Orion arm of the Milky Way galaxy, about 26,000 light-years from the galactic center. The solar system's entire structure is held together by the Sun's immense gravitational force, and its formation is believed to have begun about 4.6 billion years ago from a giant cloud of gas and dust. The Sun, our star. The heart of our solar system. The Sun is a G-type main sequence star and is an average-sized star. It accounts for over 99.8% of the solar system's total mass, making it the dominant gravitational force. Its energy is produced by nuclear fusion, a process in which hydrogen atoms fuse to create helium, releasing a tremendous amount of energy in the form of light and heat. The Sun's surface temperature is about 5,500 degrees Celsius, 9,940 degrees Fahrenheit, but its core can reach over 15 million degrees C, 27 million degrees F. The inner, rocky planets. Mercury, Venus, Earth, and Mars. These planets are called terrestrial planets because they are dense, rocky, and have solid surfaces. They are the 4 closest planets to the Sun and are much smaller than the outer gas giants. Each of these planets has a different atmosphere and geological history. Mercury, the swift planet. The closest planet to the Sun. Mercury has no atmosphere, which means there is nothing to trap heat, leading to extreme temperature variations. Daytime temperatures can reach 430 degrees Celsius, 800 degrees Fahrenheit, while nighttime temperatures can plummet to -180 degrees Celsius, -290 degrees Fahrenheit. Its surface is heavily cratered, similar to our Moon, due to a lack of geological activity and an atmosphere to burn up incoming meteoroids. It orbits the Sun faster than any other planet, completing a full orbit in just 88 Earth days. A single day on Mercury, sunrise to sunrise, lasts for about 176 Earth days. Venus, Earth's evil twin. The hottest planet. Venus has a thick, toxic atmosphere of carbon dioxide, which creates a runaway greenhouse effect. This traps heat and makes Venus hotter than Mercury, with an average surface temperature of 462 degrees Celsius, 864 degrees Fahrenheit. The atmospheric pressure on the surface is 90 times greater than Earth's, which is equivalent to the pressure 1 kilometer, 0.6 miles, underwater. Unlike all other planets in our solar system, Venus rotates backward on its axis, clockwise. Earth, our home. The only known habitable planet. Earth has liquid water on its surface, which is essential for life as we know it. Its atmosphere, composed primarily of nitrogen and oxygen, and a strong magnetic field protect the surface from harmful solar radiation. The planet's geological activity, including plate tectonics and volcanoes, helps to recycle carbon and regulate climate. Mars, the red planet. Most likely planet for future human exploration. Mars, the planet's distinctive red color comes from iron oxide, rust, in its soil. Mars has polar ice caps made of both water ice and frozen carbon dioxide, dry ice. It is home to Olympus Mons, the largest volcano and mountain in the solar system, which is nearly 3 times the height of Mount Everest. The asteroid belt and outer planets. The asteroid belt. The debris field. The asteroid belt is located between the orbits of Mars and Jupiter. It is a vast region containing millions of rocky, irregularly shaped asteroids, but their combined mass is only about 4% of the Moon's mass. The dwarf planet series is the largest object in the belt, making up about 1/3 of the belt's total mass. Contrary to popular depictions in movies, the asteroid belt is incredibly sparse. The average distance between asteroids is so large that if you were on one, you would likely not see another one. Studying asteroids provides scientists with valuable information about the early solar system's conditions and materials during the formation of the planets. The outer gas giants and ice giants: Jupiter, Saturn, Uranus, and Neptune. The outer planets of our solar system include the gas giants Jupiter and Saturn, and the ice giants Uranus and Neptune. These planets are gas giants or ice giants with no solid surface, making them impossible to stand on. Gas giants are primarily composed of hydrogen and helium, while ice giants are made of heavier volatile substances, with cores of rock and ice. Each of these planets has a ring system and numerous moons. Jupiter, the king of planets. The largest planet. Jupiter is so massive that it is more than twice as massive as all other planets combined. It is known for its Great Red Spot, a giant storm that has been raging for at least 350 years and is larger than Earth. Jupiter has a faint ring system and dozens of moons, including the four largest, Galilean moons Io, Europa, Ganymede, and Callisto. Saturn, the ring jewel. The planet with iconic rings. Saturn's magnificent rings are not solid, they are made of billions of ice particles, rocks, and dust, ranging in size from tiny grains to bus-sized chunks. Saturn is the least dense planet in the solar system. It is so light that it would float in water. It has a diverse system of moons, including Titan, which has a thick atmosphere and liquid methane lakes on its surface. Uranus, the sideways planet. The ice giant. Uranus is unique because it is tilted on its side at a 98-degree angle, causing extreme seasonal changes where parts of the planet experience 42-year-long periods of daylight followed by 42 years of darkness. Its atmosphere of methane gas gives it a pale blue-green color. It has a faint system of 13 known rings and 27 moons. Neptune, the windy world. The farthest planet. Neptune is known for having the fastest winds in the solar system, which can reach speeds of over 2,000 kilometers per hour, 1,200 miles per hour. Its deep blue color is attributed to the presence of methane in its atmosphere. It was the first planet to be discovered through mathematical predictions before it was ever seen through a telescope. Moons, planetary satellites. Naturally formed bodies that orbit planets. There are at least 891 known moons in our solar system as of March 2025, with more constantly being discovered. This total includes 421 moons orbiting the 8 planets and 10 dwarf planets, and over 470 small body satellites that orbit asteroids and other dwarf planets. Beyond the planets. Comets, the dirty snowballs. Visitors from the outer solar system. Comets are celestial bodies made of ice, dust, and rock. When they approach the sun, the ice sublimates, creating a glowing cloud called a coma and a bright, long tail that can stretch for millions of miles. They originate from two main regions, the Kuiper Belt and the Oort Cloud. Satellites, beyond moons. Our eyes and ears in space. Artificial satellites are objects placed in orbit for specific purposes, from communication to scientific research. The first artificial satellite, Sputnik 1, was launched by the Soviet Union in 1957. Today, thousands of operational and non-operational satellites orbit Earth, providing GPS, weather forecasting, and relaying television and internet signals. Starman, a unique satellite. The first of its kind. In February 2018, SpaceX launched a Tesla Roadster with a dummy in a spacesuit named Starman as the payload for the Falcon Heavy rocket's test flight. The car and its driver are now a satellite orbiting the Sun. Its eccentric orbit takes it past Mars' orbit and sometimes as close as Earth's orbit. Starman is a unique example of orbital mechanics and space-related art. The Kuiper Belt and the Oort Cloud. The farthest reaches. The Kuiper Belt is a donut-shaped region of icy objects beyond Neptune, home to Pluto and other dwarf planets. The Oort cloud is a hypothetical, vast spherical shell of icy objects believed to surround the entire solar system. It is thought to be the origin of long-period comets. Exploring the solar system. Past, present, and future missions. We have sent robotic probes to every planet in our solar system. The Voyager 1 and 2 probes are now in interstellar space. Human exploration includes the Apollo program, which landed 12 astronauts on the Moon. Future missions are planned to Mars and to explore the icy moons of Jupiter and Saturn, which may harbor subsurface oceans. The solar system awaits your exploration.